Welcome back, everyone. Now for the second keynote of the day, we have with us Bruno Sanchez. Bruno is a principal scientist at Microsoft AI for Earth, and he's going to be discussing the Planetary Computer. So without further ado, Bruno, please take it away, and I hope everyone enjoys.
Hello, everyone. Can you all hear me and see me? Everything's okay? I would take it as a yes. So I'm very excited to talk about the work we are doing at Microsoft with AI for Earth. I am happy to speak also more in general about AI or any other questions. I love that this conference is made by students for students. So I'm very open to have a Q&A, not only about the topics I'm going to be speaking about of AI, sustainability, but also, I don't know, career choices. I was also a student of physics, and it took a while to progress and do the things that I'm doing now. So if it's in any way helpful, I would be delighted to steer the conversation through that. I'm also in Seattle, so it's my first meeting of the day. Good morning, everyone. But I'm from Spain, very close to where you are in Portugal. So excited to be virtually back. Let's see how the slides go. So AI for Earth is a program of Microsoft. Microsoft has it's a large company and has a really big environmental sustainability commitments. Especially around being carbon negative, water positive, land positive. It means protecting more land than we use. Carbon negative to have negative emissions, to offset more emissions than the one we do, to reduce the ones we are doing and removing the ones we cannot reduce. And this also includes historical ones. So it's a pretty big deal. Also, waste-free to aim to, by 2030, not to have net waste in the things we do. And one of the things we also do as part of these commitments is this AI for Earth, which is basically to help in environmental sustainability with the help with AI and data science. And this is a realization I had over the years. That probably you've seen too. Today, to do environmental sustainability well, it seems you need to have like 3 PhDs. It's really complicated, and you need to have a lot of knowledge on sustainability, and you also need to have a lot of knowledge on AI, artificial intelligence, or data science, but also on cloud computing. And it's really hard to do all of these things at the same time. We have a lot of urgency to achieve the goals that we put ourselves, like the Paris agreements or the missions we have, for example, for ourselves, and also helping everyone not only get the knowledge to know what we have to do, but also help everyone do that. So the AI for Earth is a program designed exactly for that, which is to help everyone, all the stakeholders on environmental sustainability, from governments to researchers, to NGOs, to companies, to everyone, citizens, to understand how to use AI for Earth. And we do that by giving grants, and this is open to anyone. So if you have ideas of what you could do in AI for Earth, I'll put a link later to where you can do that. Also helping improve the technologies the technologies that people are using to make them better, faster, and scale better, and also hosting a lot of data and environmental sustainability data. And as I mentioned, this is to help education, citizen scientists, local governments, consumers, with all of that. I'm going to try to be a little bit faster than usual because I really want to go into Q&A. So if someone wants to know more about the stuff we are doing, happy to go back to the slides or send you these slides so you have them. We try to focus in certain areas like agriculture, water, biodiversity, climate change. The reality is that everything is within the scope of what we're doing, and some cases there is more attention. Like I would argue that climate change is receiving a lot of attention in mitigation and adaptation, but other areas like biodiversity or biodiversity collapse or things like that are getting less and are arguably harder to do because there's so many ways you can tackle biodiversity. So it's an important one. We have a huge community of more than 700 projects in 100 countries that we are helping work through that. We provide technical support. We have summits twice a year where not only everyone can basically talk to each other, share their work, ask questions among each other, but also directly with our partners or experts, so we can help do their work better. You can imagine the types of people we work with NOAA, NASA, with companies around the world to help us to help get the data, to help us process the data, but also then to deploy that. We also work with companies to help them figure out how to best use this kind of technologies, with universities and other NGOs like the WRI or National Geographic. Some examples of the things we do, to go a little bit more concrete, is we do a lot of work with camera traps, which is basically when researchers have a ton of images of a place and they want to know what kind of animals are there, or if there is humans, for example, for anti-poaching or vehicles, then you put a camera that makes images every X number of seconds, and then you end up with millions of images, and only a small percentage of them have an animal or a vehicle. So we developed camera traps to sift through all of those images and just give you the ones that have animals. Same thing for sounds. It's a microphone, and then you can detect the species that are present or making noises there, or doing land cover. All of these examples, and I would argue probably 90% of the work we do is open source, and not only open source, we also make the effort to document it, to put it in GitHub, and also when it's possible, we host the data to allow others to do training and to do their own classifiers and with the data, label data that we are putting out there. This is some of the links of the work we're doing. You can just basically go to, if you search for AI for Earth, you'll find these pages. We have acoustic, as I mentioned, camera traps, surveys, also aerial, wildlife, land covers, as I mentioned. I can go into some details, but I wanted to go a little bit faster, as I mentioned. The lila biology and conservation data sets is this, what I mentioned right before, of not only we work creating the code open source, but also to make all of these data sets open so that anyone can learn and can practice and train their own algorithms to do classification. I wanted to mention a few examples of the things we do. For example, with some apps or companies you might know about, with iNaturalist. I don't know if you know about it. It's an application you can download and make pictures, and then it basically detects what's the animal or the plant. And we work with them to improve their algorithms, which helps people who are using the app, but also in the background also helps scientists, which then get all of the information of who has detected what where, which is really important, not only to do surveys, but also to see how they change over time. WildMe is another research project, which is pretty much the same, but instead of detecting the animal, it detects the individual. Like, for example, imagine a tourist makes a picture of a whale in Boston, and then another tourist makes a picture of the same whale months later in, I don't know, in Washington State. This system recognizes the same individual because of the shape of the fins, of the patterns on the whale, which really helps scientists to know about the migrations, not only of whales, but also seals or zebras or any other animal that is working through that. So we work with them to improve the algorithms. This is a little video, but we're going to skip it. happy to post the links if you're interested, or send you these slides so you can see the videos. Silveter is another company with whom we work to use satellite images to make an accounting of how many trees are there in the whole of, in this case, in the whole of America, which is really important to figure out how to protect these areas, but also figure out how is the carbon stock, how that is changing. Is it could be increased in these areas with reforestation, could be protected and from deforestation in other areas. So these are some examples of the work we're doing. There's another video which I'm happy to share with you again, but going to other examples. Ag Analytics is another company which we are helping, with whom we are helping farmers to get all the information through satellites and sensors to know how are their fields, which is really important. We need to realize that we need to optimize and figure out where the crops are suffering and what we can do to improve the yields of what we eat. These technologies is about air quality sensors, and to measure that, which is the first point to manage the air quality and figure out how we can improve it, not only in cities but also indoors and everywhere, which is increasingly the attention of more and more governments, as it should be. These are all small examples. Happy to go into details with those, but it's basically the same idea. I think you get that what we're doing is helping anyone from researchers to companies improve their code, host the data, and then help make AI at the service of environmental sustainability. Now, and this is the kicker of the work we're doing and the work we will do this year. Through all that work, we realize that there is an opportunity to make something that we are calling the Planetary Computer, which is to really supercharge all of these efforts, to put in the same place all the data, open data that is available, to put it in a format that is ready to work with all the APIs to figure out how we can consume that data and interplay with it that you might have in your own resources, and then working always in or as much as possible in the open, with open standards and open data, to create all of these applications and services and compute resources so that anyone can truly do those works on AI for Earth. I'm happy to give more details about it, but it basically, for those of you who are more technical, is using a lot of open data like satellite images like Landsat and Sentinel, putting them on Stack Catalog, which is an open format, to ask what data do you have where, and then get only the data that you need, and then using Jupyter Notebooks, Python, and Dask to really scale the compute that you need to do your work in applications that we are talking about, like classification or land cover forecasting, or, for example, flood risk in the coast, or planning, or how do you make a conservation planning for a particular region, or diagnosis, like figuring out emissions from ships as they move and are seen by satellite signals. I believe I've gone a little bit fast, but this has been on purpose because I am happy to talk more about the details of the Planetary Computer, which is not launched, but is launching late this year. And we are very excited about it. We are very excited to see how people are using it, start to use it, and see what else we can do to help people do their put artificial intelligence for environmental sustainability, especially you students, or to know what you're working on and the kind of projects you would like to do. That is a conversation that I'd like to have. And with that, I'm happy to take questions on AI for Earth, on the program itself, or how I think this could evolve in the years to come, or if you have other questions about data science or about, I don't know, Microsoft, or whatever you want to ask about. I love to help do that. And I believe the way to do that is that you can ask questions, and then I will see it on the chat.
Hello there, Bruno.
Hello, Joe.
Great presentation, very interesting. It was a bit short, but I get that because now you want to interact a bit with chat, right? Maybe.
Yeah, I'm happy to tell more about details, like for example, the kind of applications we are working on. But I thought I would leave the space not to have slides that people can see, but anyways, because I'm happy again to send them, but to have questions.
Sure. And I know that at least over here at SINFO, we have a lot of questions. It was very interesting. For example, Andrea Pereira asked, what particular sustainability problem do you see being benefited from the use of AI that would be nearly impossible for human teams to solve?
Oh, that's a really good question, Andrea. One of the examples that I mentioned before is land cover mapping, which basically means using, in this case, satellite images. It's extremely useful to know what parts of the land are planted, not planted, are urban and rural, or are planted with this crops or that crop. And in order to do that at scale, and again, think about this as a global scale, we should know, if we knew, let me rephrase it that way, if we knew what is coming, what are the plants, or what plants are suffering, for example, with crop diseases or with locust plague or things like that, it would be a huge deal. Doing that at scale is really hard. It involves, I have some slides to share if you're interested, but we estimated for just one water set here in the US, it took $1 million to do, like, send people out there and do the land classification at the level we need. Doing that for the entire US, for example, for the entire country, would be like $200 million, $500 million, and a lot of people and a lot of time. We don't have neither the time or the resources or the people to do that at the quality we do. Instead, we do it in one piece, and then we tell an AI algorithm to say, look, this is what the satellites see, this is what the people have done manually in this region, learn how that is being done, and then by doing that, we then train it to use it at whatever scale. Of course, you always keep pockets that the algorithm hasn't trained to figure out that it's doing the right thing. But this is just a quick example of the ways we use AI, not only to do something we couldn't do, but to do it way faster with the same quality and much cheaper than with the traditional methods.
That is interesting, because you're saying that if the AI isn't sure, it will ask a human to do it, right? So
that's human in the loop is something we are also taking a lot into account in all of these machine learning, deep learning algorithms that tend to be very opinionated always to know they have an answer. So making sure we also have experts in the loop to figure out where the edge cases or things where it's not really working well, it's crucial.
All right. Well, we got a lot of questions, so I'm just going to skip over to the next one.
Going.
Tiago Antunes said, hi, Bruno. This project sounds very interesting. How do you feel the recent improvements in deep learning have impacted it? Does the increased accuracy in these models cause a noticeable impact in your projects and open new plans?
Yes, very much. We see that, in particular, deep learning has been fantastic. We've seen that in so many areas. There are many examples of deep learning algorithms learning for example, radiology to detect cancer or to detect in X-rays, like patient X-rays, and then being better than experts, than doctors, to detect the cases. And this applies to all these other areas, right? So there are more and more cases. Whenever you need to classify something on an image, pretty much deep learning can do at least as good as a professional, or slightly better at the scale you're putting that. So it's certainly helping a lot.
But
now,
I'm sorry, just can it do that quickly at the same pace that a human would?
The training takes a lot of time, and this is what I was going to mention.
Okay.
The inference time, once the algorithm is trained, is super quick to do it. Also, you can scale it easier than it takes almost no effort to scale it to 1 million times, just 1 million nodes, than to have 1 million people doing that. So that's why it's interesting. The thing that is tricky, especially when you're concerned about environmental sustainability, is that it takes a lot of time, a lot of energy to train these algorithms. And for that, Microsoft is not only helping, is figuring out how to use renewable energy to train the algorithms, but also we work a lot to do transfer learning, which basically means train it for something and then reuse what you've trained to another application instead of starting from scratch. Machines have a really hard time starting from scratch, but when they know things already trained for an area, is very abstracted out to others. Because many concepts like circle things, corners, colors, patches, things that are easily transferable.
All right. We see another question by Susanna Paz. Is AI for Earth only using image-based solutions, or are there people working on genetics/genomics tools for biodiversity?
They are working on that. I would argue that because we see so much potential on geospatial images, we are focusing on that. It's not because it's the most important, as you say. There is many other efforts, and there are other projects by other people, and also including Microsoft, who is doing that. There is a project I didn't mention called Premonition, which is basically using insects, and when they eat and they move around and they collect the DNA, and then using that as then analyzing those insects to figure out what is the genetic diversity of the fields around the world, which is really interesting. There are other projects, like, for example, to have genetic banks of biodiversity, which is very important for many reasons. And yeah, it's not only images. It's just that we have decided, based on the experience of the grantees we had so far, to focus on that because we believe there is a lot we can easily do there.
It feels like an unexplored field very much. So this is
but if anyone has, like, I mentioned it seriously, if you have an idea that you could use AI for Earth with this or other topics, please go to the AI for Earth grants, and we have, I think there is a grant window that is always open, up to $15,000 on credits to help you do those things. So we welcome those applications.
All right. Well, there's another question here from Baltazar Diniz. What is your opinion on the environmental impact of large AI language models?
I mentioned a little bit that it's fairness, biases, and the ethical considerations of training large models is certainly a concern. And I already answered part of that question. Like, transfer learning, I think, is part of the solution in that sense. Being very explicit, and this is something we're working on, to know what are the biases that the data has. If you are training, for example, remember that working here with animals, and the level of regulation, but also ethics, is a different ballpark. Like, for example, if we were dealing with humans, we could not release even the training data, right? Because of GDPR, because of privacy considerations. Or if we have a data set that only has zebras, and then you try to use it with dogs, it would not detect dogs. So in that sense, we need to tell and make it clear that this data set is biased because it only has data, for example, imagine in Kenya for summer for zebras. Those are the kind of considerations of the biases and that we do. In terms of ethical considerations, there's so many areas we can start talking about. Like, for example, when we release the data of the animals, if they had location and time, we do not put it because we don't want to if imagine we had all the locations for all the elephants in a particular country in real time. It would be great, I guess, in some ways, to figure out how to predict where they are for sustainability reasons. But at the same time, if you're not careful, you are making the perfect poaching system, which we need to be careful not to do, right? So that's ethical considerations are at the center of what we do, and we do that, as I mentioned, through recognizing the biases, recognizes the needs to do that, and even how when we train them to not have an environmental impact.
All right. I'm going to skip over a few questions because this is a follow-up to this question, and it's a bit of a technical question.
Yeah.
Tiago Antunes is following up on Baltazar, especially on underwater cooling solutions. Do you think it's sustainable, or that it will also affect the underwater environment?
In underwater cooling, I think you mean like data centers underwater. Which are cooled by water. Microsoft has, they did that, and it's fascinating. Well, water is a really good dissipator of energy. So any effects of the increased heating on the water is dissipated really close to this data center itself. So I don't imagine being a problem. I guess if you put a lot of data centers very close together in one region that is already like shallow water, no currents, maybe it could have an impact, but I would say it's marginal. But the benefits are really big because we don't need to use very energy intensive air conditioning systems. Also, the conditions are extremely constant, which we've seen that reduces the failure rates for hard drives and failure rate of components. So it's a win-win-win situation when the cooling is more effective, when the life of the components is better, and the savings in terms of emissions and energy and costs are big because we don't need to run cooling on those systems.
Yeah, of course, you're saving up on a lot of energy usage there.
Yep.
Next up, we have Christian Clemente. To me, it sounds contradicting to try and tackle sustainability problems with technology because modern technology is pretty unsustainable / a big cause of pollution. What am I missing?
You have a really good point, and I would recommend a book which is called The Wizard and the Prophet, which is basically the story of two scientists. One of them, and I'm gonna be almost comical to try to summarize the book really quickly. One is like we need to be tree hugging and we need to go back to a low technology and embrace nature. And the other one says we need to solve all problems with technology. And neither of those views are correct, right? The beauty is in the center. We need to recognize that technology has helped. The scientist on the technology side is the one who invented the Green Revolution, which literally allowed the people to be fed, humanity to be fed, because it increased the yields in developing countries. The book goes a long way to answer that concern. My quick summary is that not all solutions are more technology. Many solutions are changes in culture, changes in governance, changes in attitude at the individual level, at the collective level. Neither we can solve all our solutions without technology. Just think how much we depend on technology. For example, right now, without the technology, we wouldn't be able to learn or to do a lot of the things we are doing. So I really recommend that, and I would love to know what that person thinks of anyone thinks of that book. That book has impacted me significantly. So please take a look, and if you have feedback, let me know over Twitter or something like that.
I think the key word here is sustainability, right? We have to advance in technology, but keep it in a sustainable way so that we don't impact the world around it.
Very much, yeah.
Well, we still have a lot of time for questions, which I love. I'm loving this discussion and what we're learning here. There's a good question here. On a more practical note, what do you think a computer science student can do to get a dream job like yours? How do you join AI for Earth?
Thank you for the question. My path is it's not a straight path, and I would argue don't aim for a straight path. I would argue just try to focus on the things you are passionate about, because sometimes it's really hard, but also be strategic of the kind of things that you're working on. And what I mean by that, I'll say my example, which doesn't mean that what I did is the thing you would do. Like, I'm an astrophysicist. I studied physics and then I did astrophysics, super far away from what I'm doing right now. But I was passionate about physics. I love physics, and I still love physics and astronomy and cosmology and all of those things. When I finished my PhD on solar physics, I love the fact of understanding things, and I love mathematics and everything I was doing. But I felt very disconnected from society, from the challenges of socio-economic development, from climate change, biodiversity collapse, poverty, hunger. And I started working. I moved to an NGO, and I say, hey, I know math. I want to help you. This is a small NGO, and we developed this code it's called the Global Adaptation Institute. It was great. We got a ton of attention from a lot of people because we were tackling a lot of key issues. Ended up then going to a mapping company because I liked the technology that was used for those kind of things. So the compass always is trying to use science for knowledge creation that is applicable to society. I ended up working at the World Bank for a few years, which was, again, it was using my math, not my knowledge of astrophysics, but my math and my scientific skills to help the World Bank. And then I kept working on that, and then after a few years, I saw the application for this position, which I absolutely love, and I applied, and I got it 9 months ago. It is not easy to change from being a researcher to then have the kind of years I've done. It's really hard, and for that reason, I brought the book I wish I had when I was at university. It's called Impact Science by me, and you can buy it on Amazon if you want, or I can give you all like a PDF copy or Word document or whatever. If you go to impactscience.dev, you will see the book there. But again, you can buy it, or you can ask me for a copy. I'll tweet it later, so you can grab the PDF.
All right. Tiago Antunes has another question. How is Microsoft promoting this project worldwide? Are you connecting with small organizations that are trying to help improve the status of the environment?
Yeah, we like 70%, at least 70% of our community of AI for Earth is researchers and NGOs, and we decide what we build, mostly speaking with them, because we believe are key stakeholders. Some companies will have the opportunity to have their own resources and build their own. The vast majority of people will not have the resources or knowledge to have the topical expertise for environmental sustainability, AI, or cloud computing. For them, we are building this planetary computer. It is not going to launch until the end of this year, but we are slowly starting to put things out there and speaking with some early users. So it's going to be an extremely exciting. If you are interested in a particular aspect of the planetary computer, please reach out and we figure out how we can loop you in on early access. Some of the data sets we have already available, so you can use them. The grants are already available, so you can use them. And at the end of the day, a lot of the tools we use, you can use it anyways, like Python or Dask or those kind of things. So you're going to start using the planetary computer because it's the same thing. It's just we are making it scale globally.
Mm-hmm. Well, as a follow-up to this, actually,
Yep.
Is Microsoft working with governments to find long-term solutions? This question is by Andrea again.
Very much.
Yeah.
Very much. When I say the word stakeholders, I mean it, because it's so many types of stakeholders. I mention scientists because that's where most of the knowledge creation happens. But if we want to achieve the sustainability goals, we not only need to create knowledge to make papers, and which is important, we just put them to action. Who puts that to action? Companies and governments, to summarize really quickly. I want to help knowledge creation, but we need to make sure that knowledge can be integrated in policy making, policy decisions, but also companies who are, whatever they're doing, whatever the footprint is, the supply chains, all of these things, if they knew they can deploy that knowledge or those insights easily, that's where the magic happens. And that's exactly why the planetary computer is in a unique position, because we are working with the scientists on one side, but also we are a corporate cloud. So we can help, hey, this is how you can, if you want to use these things, this is the benefits. We are doing it as a company, and we want to help you do that. That's where we achieve the 2030 goals. Otherwise, I don't know how.
Exactly. I love that, because there is this, and there has been for a while during this century, a divide between science and action, right? Because people hear these things and hear concepts, but what do we do, right? And I love that this project is not only finding solutions, but making them accessible and trying to put them into action.
Exactly. It's a key part.